Now let's explore the convergence of the Newton-Raphson method. Okay, and again we're going to be using our Taylor series, and let's start off by making the statement that if we use the complete Taylor series, we would obtain an exact root or an exact result. So for this situation, x at our next iteration, xi plus 1, would equal to the root, where x would be the true value of the root. Now substituting this value, along with the fact that f of x root equals 0, if we substitute that back into the Taylor series, we would get the following result. So 0 equals function value of f of xi plus the derivative, first derivative of xi multiplied by the root minus xi plus the error term, which is made up of the second derivative at some average value multiplied by xr minus xi all squared. Now if we subtract this equation from the Taylor series expansion that we discussed previously, in other words, that the root f of xi plus f of f prime xi multiplied by the difference between our approximation of x at our next iteration, we would obtain the following. Let's just clear that. So we would obtain the following equation. That is 0 is equal to f prime xi multiplied by fr, the root, xr, minus x of I plus 1, plus some higher order term, multiplied by the root minus our initial estimate squared. And what do we know about the difference between the root and our estimate? That is, of course, the error term. So we write this as error term lower subscript t, the true error, at I plus 1 is equal to the difference between the root, the exact solution, minus our approximation. So in other words, we can express our equation prior in the following format. That is 0, let's just change our color, equals f prime x of I multiplied by our true error at I plus 1 plus the second derivative of f at some average value multiplied by our true error at I squared. Now here we're assuming that there's going to be convergence. So both x of I and our average value epsilon are roughly, or they should eventually be approximated by the root. So in other words, this equation can be rearranged to obtain the following: that the true error at I plus 1 is equal to negative f, the second order derivative at the root, divided by 2f prime x root multiplied by the true error at I squared. And you can see from this power term here that our errors, or the Newton-Raphson method, will converge quadratically. In other words, the number of correct decimal places approximately doubles with each iteration. And obviously this is referred to as quadratic convergence.